Hi, welcome to Crowdmark Sessions, where we bring educators together to explore innovative teaching practices and redefine learning in today's world. Join us as we dive into discussions that inspire and transform the way we think about education. My name is Michelle Caers, and I'm the host of Crowdmark Sessions podcast. I'm also the co-founder and CEO of Crowdmark, which is the leading grading and assessment system for education. Our mission and values of integrity, collaboration, and community are at the core of everything we do at Crowdmark. In this podcast, we'll be interviewing trailblazers from our community of educators to hear their perspectives on learning, technology, and the changing landscape of education. I'm excited, so let's get started. Welcome to Crowdmark Sessions, the podcast where we explore technology, teaching, and innovation to shape the future of education. In this episode, we're stepping into the world of large enrollment science courses, classes that often enroll hundreds, sometimes even thousands of students each semester. What does teaching and assessing at that scale really look like? And what challenges do instructors face in keeping feedback consistent, supporting student learning, and fostering true engagement with science? To answer these questions, we're joined by two educators from Michigan State University. Dr. Phillip Delekta is an assistant professor in the Department of Microbiology, Genetics, and Immunology at Michigan State University. He earned his PhD from the University of Michigan and Bachelor of Science in Microbiology from MSU. As course director for MGI 301, which serves approximately 1,000 students annually, he has led efforts to integrate active learning and scientific practices in both in-person and online formats. We're also joined by Dr. Katherine Krueger. She's a biological sciences assistant director and assistant professor at MSU who earned her PhD in neurosciences from Case Western Reserve University, where she studied how genes regulate serotonin neuron development. She went on to complete postdoctoral research at Stanford University, focusing on gene expression in stem cells. After several years of teaching at Santa Clara University, Katie joined the MSU BioSci program in 2017. She has a passion for all things intro biology, especially DNA, and loves the fresh insights her students and teaching teams bring each semester. Together, they'll share how they approach teaching at scale, the role of technology in shaping assessment, and why building students' ability to argue from evidence is essential in today's classrooms. We'll also look to the future on the innovations and trends in higher education about which they're most excited and concerned. Phillip and Katie, thank you so much for joining us. Can you tell us about your background and the courses you teach at MSU? Let's start with Katie.
All right, well, thank you for having me, Michelle. It's great to be here and share what we do at Michigan State University. Again, my name is Katie Krueger. I have a PhD in neurosciences, and I've been teaching for over 10 years, mostly at the introductory biology level. And my main role is the curriculum coordinator for the Introductory Cell and Molecular Biology lecture course here at MSU, which is 4 majors. We enroll 2,400 students roughly each year. This fall alone, we have over 1,100 students that spread across 4 sections. There are 6 different instructors that teach these 4 sections, and we have undergraduate learning assistants, assistant instructors, and graduate teaching assistants all working with us. So it's a huge teaching team, and that my role is to coordinate all of those individuals, make sure they're prepared for their teaching role, and then also prepare materials for students that they access in their learning, and then make sure it all works together.
That is no small task. Wow. I'm very impressed already. We're just getting started. How about you, Phillip?
So I teach MGI 301, which is an introductory microbiology course, and we teach it from a molecular biology perspective. And the goal is to provide students with foundational microbiology to go on to upper level courses in my department or med school or something of that nature So my course is, like you said, about 1,000 students a year. Actually, the minority are microbiology students. That's only about 5% of my course. The majority are from outside majors and cross almost every single college at MSU. And about 40% of them are focused on some type of medical future career. So those are kind of my students. I'm also a course director for that course, so I provide kind of similar to Katie that overall vision and continuity to the course, making sure we meet American Society of Microbiology learning objectives for undergraduates, producing content, taking care of most of the administrative burden for the course as well. My teaching team for approximately 500 students per semester is one other PhD who part-time teaches and runs a lab. One GTA, and about 6 undergraduate learning assistants.
Excellent. Thank you. You also have your hands full. I noticed the microscope in your background there. That's a nice touch for the topic today. So let's get into the topic at hand. What does teaching a course with large enrollment of students per semester actually look like day to day?
So I'll start first. We both actually use a flipped format for our courses. So the students watch recorded lectures before they come to class, and then in-class time is spent working on group activities that are focused on applying the concepts and really working with the ideas as scientists would, as best as we can mimic in the classroom setting. So when I teach, I spend 5 minutes recapping ideas from the lecture, and then I have students get to work on those activities. And what I like about that format, why we use it, is in part it allows for many more of those direct interactions with students and having conversations with them about how are you thinking through this, explain to me your reasoning, how are you reasoning through this model, what does it mean to you? And so there's a lot more of that interaction that makes the class feel a bit smaller than the huge size that it really is. So that's a big part of our day-to-day, just teaching responsibility.
Okay, so I want to dig into this a little bit. The concept of the flipped classroom. So traditionally, a professor would give a lecture, students would learn, take notes, absorb the topic, and then they would go off at different times to labs, and that's where they would actually experiment with things or learn things in a group environment. Mm-hmm. But instead of doing that, you're recording lectures in advance, and then you are having the students learn it before they get there, as best they can. Mm-hmm. And then when they're in the classroom, they're working together. Are they working together in groups, or how does that actually work with 1,000 students?
Well, it's luckily not 1,000 students all coming at the same time. Do you want to talk, Phil, about how you run things?
Yeah, so what I like about the flipped classroom is that, the traditional model assumes that you sit in a classroom and you absorb all this knowledge. And I just, don't think there's real solid proof that works really well because, students tune out. There's other things on their mind or other devices in their pockets and things like that, that distract from that. So what we do at Active Classroom, they're going to do read-in, they're going to do the lectures and probably some low-level maybe assignment online on their own. But we bring them into the classroom to do what I think the hardest part about science is, which is teaching them how to think like scientists and physicians, which is the real major goal. I tell students in my course are two things. I want them to be conversational microbiologists. They're not going to be experts on it, but they're going to have a solid foundation. So they go on to med school or they go on to upper level course, they're not lost. They can speak microbiology, understand microbiology. The other arm of my course, which is where the active classroom, so this is flipped classroom paired with an active classroom, is they work in groups to discuss content. So we're going to review content, and while they're reviewing content, we're going to teach them and help them explore how they think about things, how scientists think about things, and argue from evidence as well. And that how to think like a scientist or physician and argue from evidence, you can't as easily do that in lecture. It's much better done in a group setting because the peer discussions facilitate that argument from evidence aspect. And then we come in there too to help them model it in person, like, okay, this is how you break down the process, this is how you think about this. And it's broadly done, at least in my classroom, and it's a Socratic method, asking them, why do you think this? So we can find out how much do they know and where the faulty or the limits of their thinking are, and then push them to think through that and to develop those skills. Does that cover everything, Katie, you think?
Go ahead, Michelle. You're going to ask a
Sorry.
question.
Well, I was just going to say, when you first started speaking about your approach, I thought of Socrates and, the question and answer. But just for any instructors out there who might be listening to this podcast, let's talk logistics. Mm-hmm. So if you have 1,000 students enrolled and you have 4 different sections, how many students are actually coming to class and participating in this flipped classroom or active learning environment? And then how many groups? Mm-hmm. Like break it down for me about how you can manage that at scale.
Yeah, it's not easy. It's not easy. So all of our sections are doing the same thing. So that helps. We can all coordinate on what the activities look like and what are the procedures we're going to follow to get students to do the things that we need them to do. They're usually in pre-assigned groups that we use CAPME as a program to match people up for that. And they find a link on our learning management system that gets them to the activity. They share that among their team members. So they're all looking at the same document on their computer screens, and it's got scenarios that they're going through. And so they have defined work to be going through during the class. So they're applying their knowledge, they're building models, or they're interpreting models, and we're thinking about, what if I change this part of it? How would that affect the overall process? Right. So there's very defined things that they're working through, and then we are circulating around the room, looking over their shoulders, listening into conversations, and providing, I think I would call it coaching, more so than answering questions. We are like, what do you think about this? Or, what is this? What's going on over here? Like, what are you trying to say? What are you communicating? Right? But they're mostly helping each other through those scenarios and coming to some understanding that makes sense to them, right? And mm-hmm. collective understanding. And we're just listening in and guiding. And then there's a little bit of a assessment in form of iClicker questions or something on paper that we do that also helps reinforce the idea that we are all here in this classroom to learn. We're not somewhere else trying to do this work on our own, but that community in the classroom of learning together, what we're trying to foster. And we do get I'd say 80 to 90% of students that are enrolled in this section actually there in the physical classroom, in part because we have these things that are also done on paper, in person, that we ask students to do. And so again, I don't like to necessarily force students to do things that they don't always want to do, but at the same time, if we don't have something in there that they have to be there physically for, right, they may not engage in that way, but we find that's the most beneficial for their learning.
Mm-hmm. So students are notorious, as anyone, even I dare say instructors, for not reading instructions or not reading emails or not reading memos. Mm-hmm. And I have evidence, solid evidence for that, because every September, and this September's no different, we have students signing up on Crowdmark, asking for accounts when the instructor's already told them that they will get an invite in their email. Mm-hmm. So that's one challenge that I'm aware of. And I also know through personal experience, as anyone would, that not everybody gets along. Like, I might not like my group members. So with, those two things in mind, what are the biggest challenges in supporting these students in this active classroom environment, in a group environment?
So there's like two issues there. One issue is I tell my graduate students and undergraduate learning assistants, the biggest challenge in a classroom this size tends to be communication. I think that's true for any class, but when you have 500 students or 1,000 students a semester who come from very different backgrounds educationally, they might be international things like international students, things like that. Communication is difficult. So certainly we do things to try to convey what's important to the students, and that's done through things such as like classroom attendance is worth 10 points. Having a point value conveys that this is important for them. We call it a practice exam. This conveys to them that it's important for you to come to class beyond just a traditional like emails and things like that. I mean, I even made a course agreement, which was a 2-page basically summary of the larger syllabus we have in our course. And I actually did it through Crowdmark. They had to read through the bullet point summaries, and then they signed it, and it gets submitted to Crowdmark, and it gets emailed back to them as a summary of these are the key expectations and rules for the course. So that's some ways we communicate it. As far as group dynamics, one thing that Katie already touched on, we both use software called CatMe, which comes out of Purdue Engineering School, has some research around it that they use in engineering school to form teams and with high success. And I've seemed to have had good luck with it as well. I ask students every month or so, do they like their groups? And the majority of students put neutral or they like their groups. Only like 10 to 15% tell me they dislike their groups. Beyond that, one of the learning objectives we have in our course is to work together as scientists, and because science is done as a group activity and medicine is done as a group activity, so we're explicit for that expectation in our learning objectives. And secondly, we have learning objectives that are soft skills, which are you have to be able to work in group and navigate things. So that's part of our learning objectives as well. And I linked to a Forbes article that explains what soft skills are. So yeah, I get students who don't like their group, especially early on. They met one time and they are, very worried about their group. And I tell them like, hey, you met one time, like give people a chance, give them 2 or 3 times. And I'll talk to them both either in person or by email, like, hey, have you tried this or that? One of the biggest things I'll tell them is like, if you don't like your group, what have you done to do something about it? Have you asked them to meet ahead of time? Have you asked them for their information? Have you taken any leadership? I think that's a big soft skill. Like, have you took any leadership? And I was just talking to a former student today who wants to be an undergraduate learning assistant who said that. I freaked out about the first meeting or two, came to you, and you're just like, things will get better. You'll start to jive together and stuff like that. And the biggest thing I told her to do is like take some leadership, start to try to meet with people outside of class, try to organize your group. And because she took that leadership, she said her group was way better after the first 2 weeks of the course, and she had a great time in the course and 4-pointed the course. So those are some of the things that we try to do. But, then there's times where, groups for very legitimate reasons don't work, and we just have to recognize that and then make adjustments to those groups. Right. So.
That sounds excellent. Okay, so you broke it down and addressed both things that I flagged there. So the first thing around communication and communication being really essential, I think that's a great approach, creating an assessment or an assignment that each student needs to read, acknowledge and sign, and then submit to you. Then no one can say, oh, I didn't know. Because you've got that list of completions. I think that's really a great way to approach that. And then secondly, I love this idea about leadership and taking action and without judging and saying, oh, it isn't fair. I'm not in a good group. I want to be in a better group, whatever. What have you done to improve it? I think that's excellent. Okay, are there any other big challenges that you face that I didn't mention that others may not know about, or anything around that topic?
Yeah. Well, one of the things that came to mind when I heard that question was when we have so many students, how do we give good quality feedback to them as they are developing their knowledge and developing their skills? So, certainly there are those students who will reach out with their questions and concerns, but many more are may just be there and they're kind of flying under the radar. And so, what we need to do is be able to give them feedback on their understanding that helps them gauge their learning and what they might want to do differently going forward. And so it is one of the best uses we found with Crowdmark is that ability to give on their written responses, like somewhat personalized feedback, although it's also a challenge with the numbers that we have to grade. Like we want students to know that someone is reading carefully what they're writing and giving them tips for how they can do better on their later assessments. So I think, I wish actually that every interaction would involve a personal conversation I think that it really has the way of a way of being very effective, and students really seeing that the relevance of that feedback and able to ask follow-up questions. And so we try to set up assignments when we can to promote that, but most of our feedback is of the sort where it's just a comment on their written response. And so I wish we could do more for that.
Right. Yeah.
So the way I think about feedback in my classroom is it first starts with that active classroom assignment. And the first level of feedback they get is the peer-peer interactions they have as they discuss the questions. Because somebody's going to, as you tell them, everybody knows the answer. This group of 5 knows the answer to this problem. It's just each one of you has a separate piece. And if you discuss this and give each other feedback, you will get to the right answer. And then there's feedback from the instructors as they go through this process. When we do that Socratic method in the classroom, that is immediate and highly customized feedback we can give them then and there. And then the next level is feedback through things like Crowdmark, right? They submit their essay, we grade their essay, we have comment libraries and give them some feedback there. We post a key they can look at and give feedback. What I found to put on top of the Crowdmark feedback is we have to make sure we tell them that it's important for them to look at the feedback and make time for good study habits and things like that. Because there's research that will show that if you give students opportunity and time to do feedback, you tell them, because they're distracted. They have 16 or more credit hours. They're in multiple clubs. They're pre-med. They have all kinds of activities that are grabbing for their attention. So if I do things like an exam wrapper, or we do a self-reflection, I call them in our course, where I tell them, okay, go back to exam 2, go on Crowdmark, look at the comments, look at the key we posted also on our online learning platform, and compare your answer to that along with our comments. And I want you to answer these following questions online. And it's like, okay, if you got it right and got full credit, why was that? If you didn't, why did you lose points? And then I think importantly for each one, it says like how you're going to address that, not losing points in that section of the rubric in the future, followed by the last question is like, what did you do well to study for that exam, and what are you going to do different, and try to develop a plan in the future. So getting them to use the feedback, I think, is the thing that I'm appreciating more and more in my course.
Yeah, you're both using very modern approaches to teaching and learning, like the concept of the exam wrapper. I think this is a fairly new but really innovative and successful approach. Can you explain for everyone what that is exactly?
So I'm still kind of new to it. It's going to be our second semester using it, so I'm not probably the expert. There was a lot of good papers out there, so I encourage people to go look that up. And at least my implementation is basically what I described is, first and foremost, I kind of view points as an indicator to students that I value them to do this task, and you should make time to do this task. So the first layer I have around this is, okay, this is an assignment and it's worth points. It's just for completion, and we just kind of skim through them, and we're going to check them to make sure you took it seriously. But it's worth points, so you should dedicate some time for this out of the time you're supposed to be spending on this course. So that's the first way. Gets back to that communication issue as well, right? I communicate to them this is an important thing to do. Besides, because I used some past system, like you should do this, and I would look at who's accessed the key in our online learning platform, or who's looked at their Crowdmark feedback, and it's like, whoa, that's not nearly as high as it really should be. That's kind of unfortunately low. So then I went into literature, looked this up, and we started like this process where I think mine is a probably pretty low level wrapper, but still, like, go get your feedback from Crowdmark, go get the rubric from online, compare it to, look at the comments from our comment library and some of the personalized ones we try to drop too, and think about how did I do this wrong? Why did I lose points based on looking at the rubric and things like that? That's the other thing I didn't mention. I had them pull the rubric up that we publish on our platform as well. And why did I lose points? Try to understand why. Write down why I lost points, how I'm going to do it differently in the future. And if I still don't understand it, we tell them come to office hours. to get an explanation from us why you lost points. Just don't go blindly from one exam to one exam, doing the same thing over and over again and expect you to improve both as a critical thinker and a scientist and just as your grade in the course. Because repeatedly doing the same wrong thing over and over again does not get you further in life, generally speaking. So just telling them like, hey, you have to make time to do this. Reflect on what you did and then come up with a plan to how to improve. And this should lead you to a better outcome in your course and improve your critical thinking and scientific practices skills.
Absolutely. One of the features that we offer in Crowdmark, is the idea that students can have their work returned to them electronically, and it's very easy for them to access it, and with an emphasis for instructors to give formative feedback on responses. The idea there is to encourage the using assessment as a tool for learning and not just assessing. And in conversations we've had with instructors, they lamented about the many, many hours they spent grading paper-based assessments and putting thoughtful comments for students, and then the students would never come and pick up their exam or assessment and see those comments. So it felt like the work that was put in was for nothing. I really like this concept that encourages students to go back and look and learn from every aspect of assessment, not just studying and cramming for the test itself.
Yeah,
That's great.
I just want to add to that one thing that students don't always do, they're not always reflective about their learning. They tend to think that they are what they are. They're at where they're at. And of course, what we want to do is promote that growth mindset, this idea that with practice, with that feedback, with reflecting on that feedback and your process, right, you can improve, you can get better at things. And so the more opportunities we have to promote that reflection, I think the better it will be for students. And it's just not something that students are always tuned into doing. There will be some that will do that naturally, but some students will need more assistance in terms of assignments, extra credit points, whatever it takes to promote that reflective thinking about their process.
And I think that's partly, I don't want to artifact or partly just what happens in a large enrollment course. We have very large numbers of students, and they come from a very wide swath of society we have, and some of them come in with excellent study skills, right? And this is even more so true in Katie's course as a 100 level course, but even mine as a course that's mainly sophomore and junior. But some come in with excellent study habits, some don't. And what my hope is, once again, these are these transferable skills outside of microbiology I'm hoping to give them, which is not only the thinking like a scientist, but hey, doing this exam wrapper thing, even if their next course doesn't require it, maybe they get in the habit of doing it and they improve their study skills. So when they get to that 400 level course above mine, that they're a little bit more prepared for the rigor of that course.
Certainly students who are coming from, say, for example, a private school environment are taught how to learn. But many students who come from other environments, they could be very clever and they've been able to get by just by what they know or how they approach studying, but they don't know how to learn. So first year university is often a combination of not only learning content or learning your first year courses, surviving the so-called weeder courses, but also learning how to learn at that level. So you both emphasize scientific practices in your teaching. Can you explain what that means in this context?
Yeah, so just to start on what are science practices, so those what we use came out of a learning paradigm called three-dimensional learning that was developed by people here at MSU as well as colleagues elsewhere working together on this. And these three pillars are the core ideas, cross-cutting concepts, and then science practices. And these are meant to promote authentic learning, right, engagement with content in a way that resembles how scientists think through things and how they use that content. And it's meant to be incorporated both in teaching as well as in assessment to really help students know the purpose of the information they're learning, and again, using it authentically and assessing that authentically. And so there are many different, there's 7 different science practices that are on the list. Some that we use are developing and using models, constructing explanations and engaging in argument from evidence, analyzing and interpreting data. But the main ones that we go for that incorporate into our lecture course. And both Phillip and I participated in a fellowship here at MSU to learn about these science practices and three-dimensional learning and incorporate that into our courses. And so that science practice, though, is just the skill that scientists use and are ways in which they use information, not just memorizing facts, but putting it towards some scenario or some paradigm that, again, resemble an authentic scientific question.
That's excellent. So often it's not, I think in science and certainly in mathematics, it's not always about the final answer. It's about the process, about how you arrived at that answer.
Yep.
That's also really important.
Mm-hmm.
Yeah, so one of the things, my course, we focus on mainly arguing from evidence, the data analysis, and a little bit of modeling. And at the 300 level, Katie does a little bit more modeling at 100 level, which I think is important. And the way I came to use in my courses, I really believe that, science is best learned at the bench, because that's where I learned the most science, is at the bench, both in the classroom setting and in the research setting as an undergraduate researcher. So, how do you do that in a classroom that's not a laboratory class? And what my conclusion was like, well, I can't have them do the wet work, right? But I can give them the results of that wet work and then ask them to do the second, the harder thing than even doing an experiment. The experiments are hard to set up. The harder thing yet is the data analysis, which is, take the data, and what we do is also the technique called claim evidence reasoning. We give them a question, and then they have to make a claim based on the data. And then the reasoning part is arguing from evidence. And they have to say, well, I think the bacteria is gram-positive because you gave me this piece of data and this piece of data. I know these 2 pieces of data indicate this bacteria is a gram-positive bacteria because of this information I learned from the lecture videos and the book I read before I came to class. So, we get them to construct explanations, which is scientific practice, argue from evidence, which is scientific practice. And then the hard part is I really want to move them beyond regurgitation to application. I think that's also where some of the stuff you talk to, like students who may be good but didn't have as good of a educational background to teach them how to study. They might be really good memorizers and they've gotten by on that. Mm-hmm. But when they get to my course, they really struggle with, okay, they're just not asking me, what is a gram-positive? They're asking me to identify a gram-positive and explain, what the gram-positive is from a data set, because that's what scientists and physicians do. So that's how we implement the scientific practices in my classroom.
You're right. These doctors need to know why they're doing something. They can't just answer yes and no questions without any evidence. One thing I just wanted to circle back on, Katie, you mentioned 3D. Mm-hmm. What was that again?
Yeah, 3-dimensional learning.
Okay.
And it was the 3 pillars are core ideas.
Sorry, core ideas.
Yes. So core ideas, like the big ideas for whatever field you're in. So in biology, it'd be the cellular basis of life, that structure equates with function, that there's flow, genetic information, etc. So what are the key ideas for your course? And based on your content, and then cross-cutting concepts. And those are things that apply across multiple different scientific disciplines. So it doesn't matter if you're in physics, chemistry, or biology, you're interested in patterns, you're interested in scale, you're interested in energy flow. And those are things that apply, again, across discipline. And then the science practices, the things that scientists do on a daily basis. And just to build off what Phillip already mentioned, like these are ways in which to understand how you use the information that you're gaining. You're not just assembling a pile of facts. You are trying to use them in a useful manner to solve a problem. And it really, if you have a sense of all of these 3 parts, you can actually build a coherent narrative, right, that links it all together. And it moves you beyond, I have 100 facts to memorize. No, actually I have like 5 organizing principles, and everything is connected together within those organizing principles.
Right. I think this extends even beyond academia and even into the workplace. Like, it's fine to point out that something isn't working, but that's not helpful. You really need someone to say, I noticed that this isn't working, but I also noticed that it's working in this other way. Maybe we could try that. What do you think? I think there's a lot of that next step that's missing in the world today, where people are really quick to identify issues, but not so great at providing solutions. Even circling back to my group isn't very good. Okay, what'd you do about it? I think we could all take a page from that. Let's move on here to strategies. What strategies have you found effective for maintaining consistency and fairness when working with large teaching teams?
Yeah, again with communication. Do you want to go first, Phil?
Yeah, so strategies for that, I think, are, kind of a theme that we're developing here, and it's certainly a theme for me personally. As course director, I provide some leadership and guidance to everybody who's great in our class. So in our class, that's going to be the PhDs and GTA graduate students that do primarily the grading that we have to do. So that's first and foremost. And once again, communication. So how do we do that? So in my class, when we grade something, first thing we do is we get everybody who's going to grade together into a room, and they look at first I post a draft of the rubric and the key. So the rubric, just so they know what it looks like, we talk about that early in the semester, and we set that so we have pretty much a standard rubric the whole semester roughly. But then we have the answer key, and I post it online. They give me some feedback. I'll make another draft of it. Then we get in a room together, and physically in a room together, and discuss, okay, do we think this key works well? Is it clear? What we're asking there. Is there anything that we're missing that should be there? Does everybody have a common understanding of what we're looking for, what elements in an answer we are looking for when we're grading? And then we follow that up with, once we're happy with the key, we go on Crowdmark together, and we'll grade about 20 answers together as a group of 4 or 5 people. And we try to grab students that have a range of answers. So like this one looks like it's going to be a 4.1. We'll grade a few of those. This one looks like it's going to be in the middle. This one looks like kind of a lower scoring answer. And we grade them together. Like, okay, what do people think we think they're in? Really, when we do that and we're looking at the Crowdmark and look at the response there, we look at the key, that flushes a lot of things out where we may have had a different interpretation of what that word meant or what was the most important thing in here. That gets worked out as a group. And then we will tag those as we go through Crowdmark as examples, like an example of a high performing answer, a middle performing answer. So if you take a break and come back to us like a day later, I usually try to go back, and I encourage everybody to go back and read through a couple of those to jog your memory about this is what we're kind of looking for and stuff like that. And we try to do a lot of grading, honestly, with a lot of communication through Teams, through Crowdmark. If my graduate student's uncertain about one, I tell them don't grade it, just flag it, tag it for me, and I will come look at it, and I'll either grade or we'll have a discussion about it or something like that. Or that we see a habitual issue come up, we'll tag it and come back to it and address it accordingly. And I think the last thing that I like to do is we make everybody QC. So especially if you have more than one person grading a question, that person has to go grade 20 of the other one that somebody graded on Crowdmark. So if Bob and Joe are grading the same one, Joe's going to grade 20 of Bob's going to grade 20 of Joe's, and then I usually go in there and grade a few of them as well as a final QC check to make sure that we grade it similarly and the students are getting good feedback and it's fair and equitable if there's multiple graders, especially, and things like that. And that what I feel like, is going to be most useful product for the student to get back is happening. So that's how we try to make sure it's fair in our course. And then lastly, once again, I think that exam wrapper idea helps as well. Students go and look at it. They can ask questions about, the grading and things like that, and what the proper responses were, things like that. So the students get the final look at everything because of that.
Yeah, it sounds like that first group grading exercise that you do promotes clarity and
Yeah.
confidence in the
Yeah.
graduate students for, okay, I wasn't 100% sure if this mattered or didn't matter, but now I know. And here's some examples so that if I am in doubt, I can reference them. And then if I'm really not sure, then I'll just flag it. And what do your grad students call you? Do they call you professor? Do they call you by your first name?
They call me Phil.
They call you Phil. Okay. So they're grading and they're like, I don't know what to do with this one. I'm going to flag it for Phil.
And on the other hand, too, sometimes we get graduate students that are maybe a little overcompetent or have the incorrect interpretation of things, too. So I think those phenotypes both exist as our graduate students. And sitting down, grading with them each time, and getting a common understanding helps avoid that. Doesn't always avoid it, but that's where the QC comes in at the end. So at the end, we make sure we're on the same page and we're all giving good feedback and stuff.
Mm-hmm. Mm-hmm. Do you have anything to add, Katie? Because I have a comment, but I don't want to sidetrack things.
Well, I do a lot of the same things actually that Phil has already mentioned, except our grading is mostly done asynchronously because we're a larger grading group. But I have what I call a living rubric document where I'm adding examples, but I'm inviting other graders to ask questions, make comments, tell me I'm wrong and how I'm thinking through something if that's warranted, add their own examples. So they have a lot of autonomy and a lot of, I think, buy-in into the grading process so that everyone feels like they're given to share their information. But, there's still gray areas no matter how many examples we provide. There are still interesting things, unexpected things that you come across as you are grading. And so, we will, being human and having different experiences and backgrounds, we will decide things differently, which is, so one thing I can tell students once grades are released to incentivize them to look at that feedback is, we might have made a mistake. Let us know if you think we did something wrong. Look at that feedback, ask questions. We do try to empower our graders in that, I might look at how they grade it and say, I don't agree with that, but I'm not going to go in and change their grade that they gave. I'm going to go to the grader and say, can you look at this again? Can you think about this? And especially if a student raises concern about the grading, I won't talk to the student to change the grade. I'll talk to the grader to say, can you look at this again? And, if you want to keep it this way after reviewing it, leave a comment for the student explaining your rationale. Or if you change it, leave a comment explaining your rationale. But I think it's important that the graders feel like I have their back and that supporting them and helping them evaluate their own work and be reflective about their process and giving this feedback.
Absolutely. So thank you. I'm glad I let you go first because my comment is this: you have both provided the essential argument about why grading needs to happen in a human-to-human environment, and that why AI will not be sufficient to grade student responses in a responsible way, at least at its current level of ability. Having reasonable people looking at student responses and then having a dialogue about it and being open to feedback, either from your students or correcting or them correcting you or whatever, this human-to-human interaction is critical to making this whole thing work. So thank you for that.
I hope that continues.
I sure hope it does too. Okay, so this is a great segue into the next question, which is, how have changes in education technology, from grading platforms to online learning tools, influenced the way you design and run your courses?
So, both Katie and I use a flipped classroom, so we're very reliant on technology, both for the flipped classroom standpoint, which is true for a course of any size, but I think technology becomes an important resource for us to manage large courses, especially when you consider that the number of instructors. Like I have 2 PhD level instructors for 500 students, so having different tools can help us provide a better learning experience, a better outcome for students. So we have our online learning platform. We use that for our flipped classrooms where the students can get the lectures. We use an electronic book which has built-in videos and flashcard tools and stuff like that. We ask students to purchase and use, when I look at that book, this is one of my selling points. I pulled my textbook from my microbiology class out. And like, here's my textbook. It's paper. It's stagnant, has no study tools in it, and it's covered with highlighter and writing in the margins and stuff like that. You get the built-in, tutoring tools, 3D models. It will read it to you even if you don't have time to read it to yourself. So I think that's a great thing, especially when we struggle to get students engaged with books and things like that. The other way is, how we provide feedback on scale, which is how I became familiar with Crowdmark. It was one of the solutions when I went to some seminars that I could have used to give feedback on scale. So if I don't have Crowdmark, the way we did this course before was, for one, we would get in a room together, basically lock ourselves in a room, and with pizza and grade nonstop from 8 until 6 to get most of it, if not all of it, done. And you would have the stack of paper in front of you. You would grade your question, because there would typically be 2 or 3 questions, hand it to the person next to you. They would grade their question and just go around the room, and then have this giant, massive pile of papers. I was always definitely afraid of that would get lost, or my car would catch fire on the way to class or something like that, and we would lose all this information. To now where, okay, I can have the best of both worlds. I can have a paper assessment which addresses some of the technology concerns we have with things like AI. So I can do that paper assessment I still want to do, but I can have all the advantages of electronic grading, which is that, hey, there's flexibility in the grading platform, both as far as the comments. Like if I need to go back and fix a typo, which occasionally happens in my comments, it gets all fixed for everything in Crowdmark. I don't have to, even though we do tend to at least start grading together, we can grade for 3 hours together, feel like everybody's solid, then we can grade at our own pace for the rest of the week, and we don't have to be locked in a hot room with stale pizza for a whole day. And then, it can provide richer feedback than I would otherwise. I couldn't ask the questions that are in depth, because we ask pretty in-depth questions. They're, arguing from evidence, arguing from data. I couldn't do that level of questions without Crowdmark. When we went to Crowdmark, we could increase the scientific practice in our course because we could ask deeper questions, because it was easier for us to provide quality feedback for them to learn from. And lastly, is one of my favorite parts is I don't have to haul papers across campus and hand them back to students who half the time, like you said, wouldn't pick them up, would lose them. Or my favorite would be come to office hours and like, I don't understand why I lost points on the exam. Okay, show me your essay. I don't have it. Okay, well, I can't tell you if I can't read it again. Now I just go, hey, that's fine. Here, I'm going to pull up Crowdmark right now, and I can tell you, we can go through it together right here because it's electronic and you can't lose it. Because it's always there, and if you can download it and stuff, it's great. So those are some of the helpful ways, but especially as budgets are always a concern and things like that, technology is definitely a tool that I feel we have to be aware of as large enrollment instructors, to try to always provide the best course possible with the resources we're provided with.
Right. So just a quick summary of that is you talked a little bit about edutainment, where you get, interactive content. And, I even imagined maybe a student wearing headphones and going to sleep listening to the content in the chapter, hoping it would just sink in. And then you gave a really great endorsement for Crowdmark. So I'm really thankful for that. I appreciate it. And you certainly hit on a lot of the key reasons that Crowdmark is being adopted across universities everywhere, is all those ideas of a secure digital copy of an assessment that can't be altered after the fact, and the fact that people don't have to carry around paper or eat stale pizza for 8 hours in a hot room grading by hand. Not to mention the detailed feedback that you can give to students. Katie, do you have anything to add on to that?
I was just, when Phil was mentioning sitting around and passing around papers to grade, I envisioned what we did, which was having folders that we had to ship from one person to the other across campus to get their question graded, and having a schedule, who's got which version and all that. Bad memories.
Yeah. Yeah.
Yeah. No, I don't have a whole lot to add to that, except that just we rely on technology because it's the best way to deliver all the information that we need to our students, and also to get feedback from them, both, just feedback on their understanding as well as for us, and then give them feedback on their understanding in terms of the grades and feedback words that we provide.
Right, right. So the world has changed a lot in the last 5 years. And I'm wondering, from your experience, how have today's students changed in the way they engage with science courses compared to even 5 years ago?
I think you've already hit upon the fact that they don't always read as well as we would like them to read.
I think that's always been the case. I mean, I don't think that's new.
Yeah.
I have highlighted in my textbook to show you that I read, though.
Yeah, I think a lot of people have pointed out that what they're able to get students to read, the reading assignments they're able to assign to students is decreased. I mean, we back in the day used to tell students, read your textbook and then come to class and we'll do these application-based activities. And we've since, in the past 5 years, mainly due to COVID, but we were already trending this direction, shifted to providing these recorded lectures that are, me talking to students and showing them how to think through things. So we're already recognizing that challenge, that it was becoming harder to just assign reading. But I think there's just so many more distractions as well. Mm-hmm. There's people have shorter attention spans. They're used to instant information, instant feedback, or they have other things that they're interested in. They think they can multitask and be on Instagram and Snapchat and be in class doing their classwork, doing their homework, all these things all at the same time.
Mm-hmm. Yeah, there's a lot of noise.
Yeah, I just an example came to mind when you said about that instant feedback. 5 years ago, I would say a discussion board was, used moderately well on our learning platform. So it's traditional discussion board. You post a question and people get on there and respond to it. But when I talk to students, we have very little activity now because they can't get the feedback, within 5 minutes or less. It's just, they're not going to do it. So that more traditional discussion board, I think, is dying essentially in classes. One of the things I was going to say too is I think that there is more of an emphasis by students about their undergraduate degrees as a means to end, and that tends to be like to get to job X or go to medical school, and it's maybe a box I have to check or something I have to go through to get there, and not to appreciate the value of an undergraduate education, a liberal arts education. And I think that's even more important in the realm of AI, that, we're not here just to, learning facts and things about fields are important. But once again, get back to the idea that part of this education is just not getting a foundation of knowledge to use, but how to think, that Socratic method, how to argue like a scientist, how to analyze data like a physician. And that's really the value to college education. That's why we do a flipped classroom. That's why we interact with students in the classroom and try to teach them to think. Even my lectures have aspects we call applications, where we go through, like, here's a piece of data that's related to the traditional lecture we gave you. We'll try to break it down to the scientists and try to model that even through the videos, which doesn't work as well as in the classroom, but it's a step to get into the classroom and doing it. And I tell students, when you leave here, you should be able to think and argue and even debate, civically debate, which is something I think is lost with technology, in a society that is a representative republic, right? And you have to have these skills of functioning society. And these skills are even useful to things such as buying a house or car. They always look at me funny, like, what do you mean by that? And I'll go pull up an Excel sheet when I bought my last car that has just data. Like, okay, here's the 0 to 60 miles per hour. Here's the miles per gallon. Here's the capacity it has. I made some bar graphs and stuff like that. Katie knows I would actually do something like this. This isn't a lie. We worked together. We taught together for a semester. She knows I'm like this. And like, here, I argued from evidence which vehicle to get. I thought like a scientist physician about what vehicle, what house to get, or what investment to make and stuff like that. This is a skill that's transcendent that you don't innately have that we're going to teach you.
Phil, I have to ask, what car did you get?
That was a Chevrolet Traverse. My dad works for GM, so I was already kind of limited to General Motors because I get a discount.
All right.
But
so that factored into it. But a Traverse, is that like an SUV kind of vehicle?
It's a large crossover. So we had a smaller crossover, and we have 2 kids who are getting larger, and they have friends and soccer and things like that. So cargo capacity was the concern. How many people it could hold was a concern.
Absolutely. There you have it, folks. A unintentional recommendation for your next scientifically proven car. Katie, do you have anything to add there? Because I think, Phil, you kind of answered this a little bit, but maybe I'll be more explicit about it. So looking ahead, what trends or innovations in higher education are you most excited or concerned about?
I'm going to raise a concern. Definitely AI misuse.
Okay.
Is something that I'm concerned about. I think a lot of students, more than we would like, are thinking AI is going to be the solution to all their struggles. It's going to provide them all the answers that they need, and that's just not the case. And I think when you can sit down with students and have them reckon with that information, you can show them where it falls short in specific ways. And it's not going to, as we said earlier, it's not going to address all the things that they need to know. It's not going to teach them the skills that they need in order to be successful outside of the classroom necessarily. And, I can look at output of AI and assess if it's good or not because I already have done the work to understand things and I know the context for the answers. But someone without that context that just takes it wholesale and says, yeah, this is the answer, like, it could be anything, and they have to accept it as the answer. So it's not going to be helpful if they don't have someone else checking that work and giving them that context. So.
Some of the AI central characters, like Sam Altman and Elon Musk, have painted apocalyptic future scenarios of AI and robots overtaking, kind of like the Terminator Skynet issue. Any concerns about robots and AI taking over humans?
You mean like in a classroom setting as instructors, or
taking over the world?
Taking over the world?
Yeah.
I mean, this is kind of out of my wheelhouse as a microbiologist, honestly. I do enjoy the Terminator movies, so, I think these are interesting questions that, I say not as a microbiologist, but as an instructor that we have to think about, and maybe even as a microbiologist we have to think about, because I think these are paradigm shifts like the Industrial Revolution and things like that, and that the more minds we have thinking about this, better solutions and better use of, and even guardrails will be developed. So when it comes to technology in a large classroom, it's always interesting because I feel like you want to be a little bit cautious about it. So when I sometimes teach a smaller course where it's like 15 students in the summertime. There I feel like I can be very creative, right? I can do lots of different things because I can have very close oversight of each of the students and things like that. I know I can have, much more control about how things are being implemented because that's only 15. It's 15 students. I can have, closer eye on everything. But when it comes to 500 students or 1,000 students, changes are much more consequential because you have 500 students or 1,000 students is going to affect. So you have to be careful about when and how you implement changes. And the other thing is the large numbers play a factor. Some minor change you think is always not that big of a deal. Sure, it isn't for 495 of my students, but 5 students are in some situation of or thought of something that I never have thought of, and it impacts them in a different way or an important way that I have to consider. So we have to be careful, about that. I think once again, I will argue that if we want to make college valuable to students going forward with things like AI, we have to get across the value is that it's going to change and how you think and analyze the world. And that's an important thing that you have to be able to think independently. You can't ask AI to do all your thought processes, or if you want to use AI effectively, these skills will make you better at using AI because you can dive down on that. If I use AI about something, I don't stop with, just give me the answer. Is it the X or Y? I'll ask like, okay, give me references for that. So I can go look at the primary literature. I can go and see if that's actually a legitimate interpretation of things or not. So teaching them like, hey, you're going to be more effective both in your personal life, using AI, and in your career life by the skills we're going to teach you to think like scientists, physicians, and do those scientific practices. And I think that's a much better selling point versus just saying like, okay, we're going to stuff your head full of a bunch of facts and give you a piece of paper on the way out, and that should lead to a job, which I think is how some students unfortunately get sold on college, and that's the wrong way to sell it. But interestingly too, Katie talks about worries. I have those worries too, but we also are doing a research project that we hope will help, would use AI to help address disparities in knowledge between our two courses. So Katie's course is an intro course to my course, a prereq to my course. And we're right now studying like how much knowledge do students from her course retain by the time they get to my course, which is usually 1 to 4 semesters later. How much do they retain? How do they apply it in my course? Where the knowledge gaps are? And so can we better align our two courses? That's one aspect of it. And the second aspect is, okay, once again, I have 500 students. It's not easy for me to remediate 50% of the content they were supposed to retain from Katie's course. That would take up half my semester or more. So I have to give them tools to do that on their own. And we do things like we do a pre-course survey of their knowledge so they understand where their gaps are, and that's part of our research. And then the tool we eventually want to do is, okay, can we take where we know their gaps are, can we take her content and my content and somehow, I'm not an AI expert, but I'm trying to slowly become knowledgeable about this. Can we develop like a tutor that they can go to and go, okay, I'm rusty on this concept from BioSci 161. Can you help me review this concept or help me understand how to transfer that knowledge and make those connections between BioSci 161 and MGI 301? Can you talk me through that process? And I think it's a tool. I don't think it replaces instructors. I don't think it replaces office hours, but I always like to tell students, when you study for this course, tell me how you study. If you tell me you just do one approach, you are not effective at building a house of knowledge. I always like to describe it as a house. You don't build a house with just a hammer, right? You need screwdrivers, you need compound miter boxes, you need circular saws, and AI is just going to be another one of those tools that are going to help us be more effective at building that house of knowledge that you came to this course for.
I think that's an excellent summary, that AI is a tool just like any other tool that we have, and that the output needs to be evaluated each time on its merit. And I think that we need to teach students how to effectively do that. And it's, I'm grateful that we have educators like you both out there that are taking on that task and teaching, particularly future practitioners in medicine, these critical thinking skills. So thank you again for joining us today, Katie and Phillip from Michigan State University. It's been a really interesting conversation about managing large-scale classes in science courses.
Thank you.
Thank you.
You've been listening to Crowdmark Sessions, where we explore the ideas and innovations shaping the future of education. If today's conversation inspired you, be sure to follow and share it with a colleague. To see how Crowdmark is helping educators unlock potential and transform assessment worldwide, visit crowdmark.com. We'll be back soon with another episode. Until then, take care.